everyone, my name is Timothy Lee Grant, and today we are back at it again with more LeetCode, continuing on the LeetCode journey. So, as I said in my last video, I am going to be changing my strategy. I am only going to be focusing on one topic. So, I am going to narrowly focus on depth-first search. I'm going to keep doing problems, until I get to the point that I feel I really understand depth-first search. And then if I get a problem, which is depth first search, I can solve it. Then I move on to the next topic. Not this kind of, I'm going to be doing bitwise manipulation and then doing depth first search, then breadth first search, then dynamic programming. No. Just focus on one thing. So, just filmed the video that which one was it? It was this symmetric tree. As you see, there's no check right there because I wasn't able to solve it, but I did look at the answer and I went through it, and in the video, I looked at the answer and I went through it, and I think I kind of understand what's going on. In this video, we are going to be doing a different problem, and let's see if we can solve it. Let's see if it is. I'm also going to be doing another easy. I'm not messing with the mediums right now. I don't think I can solve mediums. I'm trying easies. Okay, so let's try this path sum. Let's see if this is a problem that I'm capable of doing. Fresh cup of coffee. Let's go. All right. 112 path sum. Given the root of a binary tree and an integer. Okay, so I'm given the root and I'm given some integer, target sum. Here's the root, here's the integer, target sum. Return true, so I need to return a Boolean, true or false, if the tree has a root to leaf path such that adding up all the values along the path equals target sum. Okay, a leaf is a node with no children. Okay, so what I think this problem is asking is I am going to be given some number. Let's say it's 10. And I want to know, can I go from this root node and all the way to one of its children such that I arrive at a leaf node, and that leaf node's path all the way up to the root nodes equals the sum of each of those nodes equals this target sum. So, like for example, I just said target sum is 10. Now let's check if this node right here, this leaf node, follows the condition. So we have 2 plus 11. Nope, already we broke the condition. Now, what I'm thinking, I'm starting at the root node. I'm going to continue. I'm going to come down here. So 5 plus 4, so we have 9. Now, if this number were 12, and I said the target was 10, I know immediately I can just throw it away. I don't need to continue recursing down lower if this node causes a sum to be higher than the target value. Why am I able to do that? Because it is always going to increase. The path is always going to be increasing. So 5 plus 4 plus 11 plus 2. So the sum is always going bigger. If I am at this node and I say I am already larger than the target, there is no path such that I am going to be able to continue down this path and still arrive at the target sum because I'm always going to be increasing my number. So I'm going to start at this root node and I'm going to check, is this bigger than my target? If so, I am just going to stop recursing down this path. I'm not even going to visit the left or the right, because let's say that this is 10 right here, and let's make it 100. Okay, this root node is 100 and my target is 10. Is there any way is there any path such that my path down will sum up to be 10? No, because right here is 100, so I don't even need to go down on the left or right. So that's a base case. So I'm also thinking, do I need a helper function, or can I just do it from this has path sum? I think I can, because I'm returning a Boolean. No, I do need a helper function because I'm going to be keeping track of the, because I'm going to be keeping track of the sum. Def recurse, and I'm going to have the node. I am going to have sum or path sum, and then I have access to this target sum. Now, if node, or if what do I want to do if there is no node? So if there is no node, do I return true or false? Let's I guess look at here. Is it guaranteed the number of nodes in the tree ranges from 0 to 5,000? So that there will be no everything that I just said about being able to prune, because I'm always increasing my sum, is wrong. Everything that I just said was wrong, because the node values are allowed to be negative. Okay. Node values are allowed to be negative. So I guess I need to recurse through the entire tree. All right. So I only check once I hit a leaf node. So if not node.left and not node.right, then I have to check. What am I checking? I am checking if path equals target. Okay, that's one. Now, okay, so I come down here and I say, nope. What about the case like right here? This is a leaf node. Or actually, I mean right here. So this one, I don't want to recurse down here. I do want to recurse down here. So I'll just like do if node.left, then recurse node.left path sum plus node do I want to give the node that I'm currently at, or do I want to give the node that I will be passing in? So I'm going to call this function, so if root, then I'm going to recurse, okay, else return if there's no tree, then the only time that this case would be valid. Like, what do I do in the case where there is no example? So here, target sum. So the root is here. Since the tree is empty, there is no root to leaf paths. Okay, so I just return false. False. Okay, so I want to pass in the root, and I'm going to be returning this. Return, because this function is going to return a true or false. And then do I want 0 or do I want root.val? I think I want 0. Yeah, I think I want 0 because that means the path, and so far I have no values in this path. And then right when I do this call, then I have a path. So then when I go look at 4, I look at the path means all the values before it, but not including 4. Although I think you could do it either way. You just need to be consistent. So I'm just going to say, if this is 0, then I need to add the current node. So that would be node.val. Okay. Okay, so I really like how a lot of these recursive functions, you're able to do it very elegantly, and this function returns a boolean, and that boolean gets passed up and down, and you do these checks, but I always fumble when doing that. The way is possible equals false is false, and I think I actually will just return is possible. So recurse and then root 0 and then return is possible. I think I'm going to keep this is possible value as kind of a way to keep track of if any of the paths hit. Because if this one hits, I don't want to then go and look at this path and say, oh, this didn't, it's false, and I return false. But I really like those elegant solutions where you don't have to create this kind of like placeholder variable and then just I don't like it. It's not very elegant, but okay, first I guess step 1 will be try to solve it don't get too ahead of myself. Try to solve it because I haven't been doing very good at solving problems recently. Number one, try to solve it and then see if I can make it more elegant. But first step, let's not get too ambitious, okay? Let's make sure we know our level. Okay? I have not been on a roll recently. Things have I've done like 5 problems. The past 5 problems that I've attempted, all of them I failed to accomplish it. So maybe don't get too ambitious. Maybe just let's focus on just solving it. So I'm returning is possible. So now in here I want to check. So if path sum plus node dot val equals target sum. If yes, then what do we do? Is possible equals true. Then return. Okay, so if this is the case, then I want to change this is possible. It's not a timekeeper. Like state keeper. I want to change the state keeper variable to be true. Say, hey, we got it. And then if I have reached a leaf node, well, then I just want to return anyways. Regardless of if the target was hit or not, I always want to return. Okay, so now I'm going to do recurse left and then recurse right. So if node.right, then do the exact same thing here. Recurse right. Now let me think through it because I think I'm done. So we have an implicit base. No, we have like an explicit that we hit a leaf node. So here it's going to end because bam, bam, it ends. We return, come up here, go down here, it ends. This one, it's going to go down the left, but it's not going to go down the right. So that's kind of like a base case as well because we're just not doing that recursive call. We come up here, do this, and same thing, we hit the base case there. This has an implicit base case because we're not hitting it here, but we are hitting it here, and then this is our base case right there. So I think this is the solution. I might be brave, and I will just do submit. I'm not even going to run it. What do we think? Yeah, let's go. Judging. Oh. Why? Okay. Target sum is 22. I was hoping that this would work. I kind of suck. I really have my hopes up. I've failed 5 times in a row now. I don't want to make this 6. Why? This doesn't support visualization. Yes, but why? Why? What's going on? All right, so I'm going to come back here. Is it possibly the fact that this variable Is there something strange with this variable? Like, okay. And then self.target sum equals target sum, and then self.target sum. Okay. Is that the problem? No. Is possible is not defined. Is possible. Self.is possible is not defined. Where did I call is possible? Okay, come on. Oh, that was the problem. Yeah! Okay, that was the problem. I would have been so upset if that was the problem and I wasn't able to solve it. And then I had to declare defeat. I had to go to Copilot and ask what I did wrong. And that's what it told me, is that the is possible is outside of the scope of that function, and that's why my algorithm was correct, my data structure was correct, everything was correct, except it was a Python problem. It was the Python syntax and which variable is in memory, which variable is in scope, not in scope. I would have been so like down, but I'm okay. Got it. Happy. I broke my losing streak. I had 5 losses under my belt. Now I gotta win. All right, we can reset this. Bam. We are so back. Okay. So I'm going to be right back, actually. Literally, I am going to stop this video, and then I am going to press play again, and we are going to do another LeetCode problem. We're going to hit this back to back. Okay, I just got done previously solving a LeetCode problem. Well, I didn't solve it. Failing to solve. Wasn't able to get it, but I looked at it, the solution, tried to figure out what was going on. Then this video, I just started this video, finished it, got it, success. Okay, now I'm going to just immediately go into another video. So see you guys in that next video. Thank you for watching. My name is Timothy Lee Grant, and subscribe if you would like to. And see you in a few minutes. Bye-bye. So happy I broke my losing streak. Let's go.